back at AP Review. This is 2011 AB Free Response 3. Let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine of the quantity pi x, as shown in this figure, but better on the real AP, so use their figure, not mine. Part A, write an equation for the line tangent to the graph of f at x equals 1/2. Okay, so anytime we're asked to find an equation of a tangent line, right, to find the equation of any line, we need two things, right? So number one, we need a point. So the point we actually already have, it's 1/2 comma 1, right? They gave that to us on the graph, right? The second thing we need is a slope, but when we're talking about tangent slope, what we want is f prime of 1/2, right? So I need to find f prime, and then I need to plug in 1/2, right? So somewhere, right, I'm going to find some space. It doesn't really matter where on my paper, like wherever my part A is, but I'm a little more constrained here. I'm going to write that my f prime of x is going to be, I drop the 3 down in front to get a 24x squared, right? So f prime of 1/2 should be a 24 times a 1/2 squared, which is a fourth, which means I get a 6. So my slope is a 6. Then my job is just to write the answer. Y minus the y value equals m, which is the 6, x minus the x value. And that is the equation of the tangent line. Now, they didn't say solve for y, but if you want to solve for y, the safest way to do it is to just add the plus 1 over and keep it separate after the parentheses. So 6 times the quantity x minus 1/2, and at the outside put a plus 1, right? Either of those would be fine. Again, it doesn't matter which of those options you pick. You can distribute the 1/2 and then clean up, or I'm sorry, the 6 rather, and then clean up. But again, if you do something wrong, it's on you, and you can take a right answer and turn it into a wrong answer. Part B, find the area of R. Cool. So when I want the area between two curves, I need to integrate top curve minus bottom curve. Now the curves never switch places, and I know from my basic knowledge of graphs that this has to be the x cubed, right? And that this has to be the sine. This has to be g. So when I go to do part B, I want to integrate from the first point of intersection, which is 0, to the second point of intersection, which is 1/2, of g of x, the top curve, minus f of x, which is the bottom curve with respect to x. So that's going to be the integral from 0 to 1/2 of sine of pi x minus an 8x cubed with respect to x when I do the antiderivative for this. Now, technically this is u sub, but really if you can understand that when you derive this thing, you would end up timesing by pi every time. If you integrate sine pi x, you're going to have to divide by a pi. So you're going to get a 1 over pi. When you integrate sine, you get negative cosine. So it's going to end up being a negative cosine of pi x. Right? And then when I integrate this, I'm going to up the power by 1 to 4 and divide by the new power. So I'm going to get minus a 2x to the 4th, and I'm going to evaluate from 0 to 1/2, right? So when I plug in my numbers, right, so I'm going to get that this is a negative 1 over pi cosine of pi over 2, right, because it's pi times a half, minus a 2 times a 1/2 to the 4th, right, that's the top bound, minus, in parentheses, negative 1 over pi cosine of 0 minus 2 times 0. Now be careful, because a lot of times when we plug in 0, we get so complacent thinking that the plugging in 0 is all going to cancel, but here it won't, because cosine of 0 is not 0. So cosine of pi over 2 is 0, right, because pi over 2 is right here, and the cosine value is 0, whereas here at 0, the cosine value is 1. So this is going to be a 0, right? And then 1/2 to the 4th is the same as a 1 over 2 to the 4th, or a 1/16. So I'm going to get minus 2/16, or 1/8, if I want to make my life a little bit easier. And then minus, in parentheses, this is going to be a negative 1 over pi minus a 0. So I end up getting a negative 1/8 plus a 1 over pi. Negative 1/8 plus 1 over pi. You could get a common denominator and clean it up, but there's really no good incentive to do that. I would leave it as is. Cool. Part C, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. Cool. So, unfortunately, they're rotating upwards, which is only frustrating because it's harder to show you based on where my graph is drawn. So I'm going to erase this stuff so I can kind of show you what they're talking about. So what they're saying is you're taking this little slice and rotating about this axis of rotation. Well, that's going to create an annulus, right? It's going to create a washer or a disc with a hole. So remember that the way one of these slices looks is a big circle minus the little hole that's missing. So pi big R squared minus pi little r squared would be the area of this thing, right? So what I want to do, or if you want, you can factor out the pi, right? It's r squared minus little r squared, right? The thing to be cautious about is it's never r minus r quantity squared. So really, the entire job I have here is to figure out what the r lengths are. So this big R, right, this big radius, would be the axis of rotation, which is 1, down to the bottom curve. So my big radius is the axis of rotation, which is 1, minus the bottom curve, which is the f of x curve, right? Or 1 minus the 8x cubed, right? My little radius is the axis of rotation down to the top curve. So 1 minus g of x, which is a 1 minus the sine of pi x, right? So my volume is what happens if I add up all of these areas. So my volume is going to be the integral from 0 to 1/2, that was a 1/2 before I accidentally erased it, of, so there's a pi, right? Pi times big R squared minus little r squared. So put the pi in front. Big R squared is going to be a 1 minus 8x cubed quantity squared minus 1 minus sine of pi x whole quantity squared with respect to x. And that's what they want to see, right? They want to see this integrand. They don't want you to evaluate it because that would be a really mean thing to do. The end.